Hello, welcome to another topic of our AI class. And in this video, I would like to talk about random forest, which is a quite popular classification model based on decision tree. So if you have not learned decision tree, please do so. Right. So random forest is, I guess, based on decision tree, and it's actually improved upon it. So what does it improve upon, right? So decision tree has a big major problem. It's called overfitting, right? Yeah. And another word is called high variance. So what overfitting means is that it fits very well to the existing data. So this is the training data, right? It's actually, if you look at the training accuracy, usually this decision tree can do very well because it can keep asking questions. But then it's actually perform worse at prediction, right? I guess to illustrate this, I want to show you maybe drawing the decision line. So think about this as the decision line for the iris data that we looked at previously. This might be pedal width, pedal length, or something like that, right? And the decision line that this decision tree might create can be something like this, right? If you let it I guess let the max depth equal to none, then it might create some very complex shape for your decision line. This one is, I guess, perform well for the training data because it's kind of like very specific to your training data. It's split things perfectly. But then as you can imagine, that this one probably doesn't generalize well to the unseen data. And something that is that is simpler, like this, is actually perform better, right? So that is something that random forest classification is actually helping. Okay. So what it's doing is that it consists of a lot of trees. So as the name suggests, the forests, right? So it's an ensemble or a group of decision tree. And what usually done is that the tree is actually the tree that is small, right? Small trees. If you recall in my decision tree lecture, I mentioned about the max depth, right? And I was saying that the tree that has large max depth is a big tree. It asks a lot of questions and it's pretty good at classifying, right? But then if your max depth is small, that means the tree doesn't ask many questions, and I guess it's more stupid, I guess, to put it simply. And I was saying that, like, why would you want stupid trees? And this is why, right? Random forest usually consists of stupid tree. But when you have a lot of stupid trees, it's actually perform well in I guess from the I guess ensemble perspective. So it's actually better at generalization, right? And this is actually kind of nice in a way that you don't need smart tree, like you don't need smart individual, but you just need a lot of, I guess, normal individuals. Like I don't know if that's kind of apply to like a nation or not, right? But I guess that's beyond this point, right? All right, so in order to build the forest, actually, I guess in addition to specifying like what is the size of the tree, you can also specify. I guess you can limit the data that each of the tree sees too. It's called the subset of sample. So I guess the tree is small, but then you can also limit the amount of data that the tree see. For example, if this is the train data, right? Okay. You might when you want to build the random forest, this is the first tree. This tree might only see like this much data, and the second tree might be training from this much data, and this is called bootstrapping. Okay, and the reason that you do this is that you want I guess you want the tree to be different. If you have the tree that sees the same data, then you always gonna get the same type of tree. But you want different type of tree, so you want to limit, like different data for the tree to be built upon. So that way you have, I guess you have variety of the tree. I guess the tree attribute, the tree types, for example. Okay. And actually, not only that, you can also limit the number of attributes that the tree uses too. But probably not gonna go to that in this lecture. Okay, but you can set that. Okay, but again, once you have the tree that are building, so what happened during prediction? What happened is like this. So in this, imagine that this is the whole random forest model. It consists of many trees. In here, it showed 3 trees, right? When you give the, the input in here, then each of the trees will predict something different because we built them differently, right? Maybe we choose different sites, and we also limit the data that each of the trees sees. So so in that way, the tree will predict different results, right? So the first tree might predict apple, second one apple, and the last one might predict banana. But the thing is that once we have all the results from each of the trees, then we do the majority voting. So in here, as you can see that the majority of the answer falls into apple. And so this is the kind of the representative answer of the ensemble itself. Okay, so yeah, very simple, right? But actually works really, really well. And this is kind of like the recommended classification model if you want to use for something in production. Okay. So if you were to use them in scikit-learn, then there are parameters that you can adjust. The first, very, very important, the number of trees, which is k. So as you can imagine that if you have a lot of trees, then you usually get, higher performance, but it at the at the cost, at the downside of the higher computational cost, right? So you might want to set it, relatively high, but not, but not too high that it makes your code run too slowly. And also the size of bootstrap sample. So this one is the choice of the limitation of the data that each of the tree sees. Okay, so if n is smaller, that means that each of the tree see only a small portion of the data. So if n is small, then maybe this tree only see this much. This tree only see this much. So that means that if you have more randomness, right? It can help overfitting, but then it can also, if the tree see, like maybe too few samples, then it might be too stupid to classify anything to be useful, right? So you might want to set them, it depends, okay? And also the number of features. This is the number of features that the tree uses to ask question. So for example, like in iris dataset, there are 4 attributes like petal width, petal length, sepal width, and sepal length. Then you can also set this d to be smaller than 4. So that means that each of the tree actually can only access 3 attributes randomly at most, and that will make randomness even more pronounced in your in your tree building. Okay, and another thing that you might want to look at is the parameter that are relating to the tree itself. For example, criterions. So this one, remember we Gini and entropy, right? And max sample, not max sample, but max feature. Oh, sorry, max step. So that is something that is relating to the decision tree itself, right? And these are the ones that are relating to the random forest, because the number of tree, right? The max sample and max feature is the subset of data and the subset of the feature that it's using. Okay, and this one, actually, let me just go back. I'm kind of confused here. So this one is the decision tree attribute. This one and also this one, right? But then this one is random forest. Okay, something like that. Okay, so again, you have more control because you have trees. You can customize each tree, and you can also customize the ensemble property itself. So that's why you have more parameters. Okay. All right, so we're gonna use them to classify again iris data, and maybe you can kind of play around with the number of trees, right? You can play around with the number of sample that the tree sees for each tree building. Number of feature, max feature, and also the max depth of the tree itself. Okay. All right. So